Coordinates and graphs. Now we have already seen what a number line is and how numbers are represented on it. Take a close look at the number line below. From the number line, it is easy to say that point A is 3 points on the left of the number line from the origin O. This is represented as A, -3. B is 3 points to the right of the number line, represented as B3. Now consider point C. How exactly can you define this point? We use the Cartesian plane. The Cartesian plane is a figure used to describe the two-dimensional location of a point. Basically, a Cartesian plane is made up of two perpendicular number lines that intersect at the origin O. The vertical number line is the y-axis and the horizontal one is the x-axis. Now this is a simple Cartesian plane. The arrows are used to indicate that the number line builds to infinity. When naming points on the Cartesian plane, we use the order xy. Point A, for instance, is 2 points along the x-axis and 3 points along the y-axis. Its coordinates are A, 2, 3. B is 3 minus 3. C is -3 minus 4. D is -5, 1. E is 0 minus 3 and F is 5, 0. Now if you join points A, B and E, you will form a triangle. We say that triangle ABE has been represented on the Cartesian plane. Choice of scale. Now on an ordinary graph paper, one big square measures 1 centimeter by 1 centimeter, and you can confirm that with your ruler. When plotting a figure, it is important to first make a sketch to see which side of the plane the figure lies, and this allows you to choose the scale wisely to accommodate the figure. However, you should avoid choosing a small scale, as this might make your work untidy in certain manipulations, as we shall see later. Remember, the scale on the x-axis need not be the same as that on the y-axis on the same plane. Consistency is what should be a concern. That is, you can have 1 centimeter representing 1 unit on the x-axis and 1 centimeter representing 3 units on the y-axis of the same plane. The most important thing is to be consistent for every axis. Whenever you plot anything on the Cartesian plane, you must always do the following. 1. Give your graph a title. 2. Label the x and y axis and put arrows. And finally, write the scale you used for each axis. Linear graphs. The ordered pair A, X, Y indicate a point on the Cartesian plane. Consider the equation y is equal to 3x plus 1. Such an equation tells us the relationship between x and y. This relationship can be represented on a Cartesian plane. The line will show how y changes with changes in x. Now, to get the points on that line, we get a set of x and calculate the corresponding values of y. For example, for y is equal to 3x plus 1, if x is equal to 1, then y will be, we substitute 1 into the equation, so we have 3 times 1 plus 1, which gives us 4, If x is 2, we do the same and you get y is equal to 7. If x is 3, y is equal to 10. Now we therefore form a table of values like this: x and y. When x is 1, y is 4. When x is 2, y is 7. We saw that. And when x is 3, y is 10. And we then plot the points, that is 1, 4, 2, 7, and 3, 10, and then you join them, and we shall have the following graph. Note that the scales are not the same, yet we shall still obtain a linear graph, that is a straight line. It does not change the line, only inconsistency will. Since the equation is that of a linear or straight line, you only need 2 points. Graphical solutions of simultaneous equations. Now, 2 or more graphs can be drawn on the same Cartesian plane. This concept is used in solving simultaneous equations. The solution of simultaneous equations is the point of intersection of the 2 lines. For example, use graphical method to solve the following simultaneous equations. 3x minus 2y is equal to 8. X plus 5y is equal to minus 3. Now we rearrange the equations. For example, we have 3x is equal to 8 plus 2y, which means x is equal to 8 plus 2y over 3. That is the first equation. And then we obtain a table of values like we did. So we pick some values for x and find the corresponding values for y. Again, for the other equation, x plus 5y is minus 3. We have x is equal to minus 5 minus 3. Again, we get a table of values. We only need 2 values. We only need 2 pairs of values. So we have the table of values for the first and the second equations. And then we plot these points and then join them. We will obtain graph of this nature. The 2 lines intersect at the point 2 minus 1. 2 minus 1 is the solution of the simultaneous equation. That is, x is equal to 2 and y is equal to minus 1. You can use the elimination and substitution methods to confirm these answers. General graphs. Graphs are very common in science and other fields to show the relationship between 2 or more quantities. The quantity whose values are selected is called an independent one, while that quantity being observed is called the dependent variable. Dependent variables are plotted on the y-axis, while independent variables are plotted on the x-axis. For example, if you record the temperature in a room for a period of 10 hours, we say that temperature changes with time. Time does not change with temperature, so temperature is dependent on time. Now suppose you choose to record the temperature at intervals. Let's say you get the following results. Now you plot the graph of temperature on the y-axis versus time on the x-axis. Now you will get the following graph. Now up to 5 hours, the relationship between temperature and time was linear. In this region, it is possible to determine the temperature at any time. Say after 4.5 hours, it will be 22.5 degrees. Now remember, all graphs should have the following. a short and precise title, a large scale as the paper can accommodate, labeled axes with units indicated. If two graphs are drawn, they should be labeled, their equations should be written, dependent variables on the y-axis and independent variables on the x-axis.
I think that math, aside from obvious careers that require math, if you're going to go work in a department that does operations research or something like that, they'll want people with specific skills in mathematics. But math is often seen as a filter or as a screen for many, many other disciplines. And so I guess what I'm trying to say is you can think broad because math actually is a solid preparation. It's a good credential to go into lots of different fields that people often don't consider at the beginning.